In this lesson, we will learn about a record. First of all, we will learn about the function of a record, then the scenarios for creating a record, and after that, we will perform hands-on lab, and finally, we sum up the lesson with the keynotes. This is the content of an A record. A records are used by DNS servers to resolve from a fully qualified domain name to one IP address. The fully qualified domain name contains a host name and a domain name. An A record does not guarantee that the IP address exists. It just provides the mapping between a fully qualified domain name and an IP address. It is possible to create the pointer record associating with the A records. When a host provides multiple services, it is possible to create multiple A records with different fully qualified domain names to point to the same IP address. These services can be in the same or different domains. For example, this OPV Web01 server provides multiple services for sales and CRM in itlifeskills.com and ciscoskills.us, so we can create multiple A records for the client to access. For example, sales.itlifeskills.com, crm.itlifeskills.com, and crm.ciscoskills.us. As you can see, these records pointing to the same IP address 10.10.0.101. When multiple A records with the same fully qualified domain name pointing to different IP addresses. For example, in this network, we create two A records for chaining.itlifeskills.com, and the first record pointing to server 1 and the second record pointing to server 2. If the hosts serve the same service, users may not notice any differences, but the requests are not sent to these hosts in a controlled manner. For example, if server 1 provides a chaining web app and server 2 provides the same chaining web app, now laptop 1 query the DNS server and it gets the IP address of server 1, and laptop 2 will get the IP address of server 2, which means laptop 1 access the chaining web app on server 1 and laptop 2 access the chaining web app on server 2. Everything looks good. However, the next time laptop 2 may get the IP address of server 1 and it access the chaining web app on server 1, and laptop 2 query the next time it get the IP address of server 2 and it access the chaining web app on server 2, which means we have no way to control which clients access which host. Now the problem becomes worse if the host provides different services, users have different experiences. For example, in this case, server 2, instead of providing the chaining web app, it provides the file service, and it means laptop 1 still can access the chaining web app on server 1, and laptop 2 cannot access the chaining web app. So we need to make sure one fully qualified domain name points to only one IP address. If a service expands on multiple hosts, the solution is to use a load balancer. User then connect to the service via the load balancer. The load balancer forwards the user request to each backend host based on the workload and the status of each host. For example, in this network, we have server 1 that provides the chaining web app. To allow users to access the chaining web app, we create the A records for chaining.itlifeskills.com to point to server 1. And when the client query the DNS server, it will get the IP address of server 1 for chaining.itlifeskills.com, and the client will access the chaining web app on server 1. Everything looks good. Now, when more users access the chaining web app and server 1 becomes poor performant, we need to add server 2 that provides the same chaining web app. To make sure the users access the chaining web app in a control manner, we need to add a load balancer. And we need to update the A records for chaining.itlifeskills.com to point to the load balancer. Now, when the client queries the DNS server, instead of getting the IP address of server 1, it will get the IP address of the load balancer. And it will access the chaining web app by sending the request to the load balancer. Upon receiving the request from the client, the load balancer will check the status of server 1 and server 2, and in this case, it finds the status of server 1 has better performance, so it forwards the user request to server 1. Now let's create the A records for chaining.itlifeskills.com. To do that, we need to open DNS Manager and expand the for lookup zones and click on the zone itlifeskills.com, then right-click and select New Host. And here we type in the host name, Chaining. As you can see, as we type the host name chaining, it automatically fills with the fully qualified domain name as chaining.itlifeskills.com. Now we just need to type in the IP address 10.0.0.100. And in this case, we want to create the pointer record. So we check on this box and we click in as host. As you can see, the host record chaining.itlifeskills.com was successfully created, and we just need to click OK and click Done. So that's it. We have just created the A records for chaining.itlifeskills.com. Now let's perform the test by pinging chaining.itlifeskills.com and hit enter. As you can see, it resolved to the correct IP address 10.0.0.100. Everything looks good. To understand what happened behind the scene, let's perform the capture on the DNS server. Here we click on the Ethernet, and as you can see, we filter for the DNS, and now we start pinging. And as you can see, here is the result. First, the client queries the DNS server and asks for the A records chaining.itlifeskills.com, and the DNS server responds to the client that the chaining.itlifeskills.com has the IP address 10.0.0.100. This is the end of this lesson. Let's read the keynotes.